Alright, we're gonna go ahead and get the lead out on this Bowman Iron Truss Bridge, which was located in Savage, Maryland. And we're gonna start off with the history of the actual bridge / who designed it. In the period when Bowman began designing in about 1840, there were fewer than 10 men in the country designing bridges by scientifically correct analytical methods. The Bowman Iron Truss Bridge was designed in 1852 by the Wendell Bolden, creator of the Bowman Truss, and one of the first to use iron exclusively in all essential structural elements of the bridge. By the way, using iron material instead of wood material was revolutionary, so this guy was like way ahead of his time. The aspect of using more iron material was also a key factor in the rapid expansion of American railroads in the 19th century. You see, the wooden bridges were cumbersome to build and very vulnerable to decay. Thanks, Wendell. Wendell Bowman, the designer and creator, was a self-educated engineer who apprenticed as a carpenter. Who knew? He adapted the technique of trussing from the practice of strengthening wooden beams using tension rods. More than 100 Bowman truss bridges were built between 1850 and 1875 for the Baltimore and Ohio Railroad. The Bowman Iron Truss Bridge was the only remaining example of a double-span trough bridge extending 160 feet used on a spur across the Little Patuxent River at Savage, Maryland. Structural engineers, architects, civil engineers, mechanical engineers, electrical engineers. Who are these people? Well, let me give you the breakdown. Structural engineers would design the actual bridge and its components. The structural engineers would most likely work with an architect. Civil engineers work mainly with drainage, site grading, and building foundations, and don't have much to do with the actual building of the bridge. The construction company hired to build the bridge would have design engineers for many required field changes of submitted approvals, and depending on the type of bridge, an electrical and mechanical engineer would also be thrown in the mix. Alrighty now let's get to this beautiful bridge and its sexy bridge mechanics. That's right, we're talking about bridge description. The Bowman Bridge is a two-span through truss resting on granite abutments at each end in a granite pier in the middle of the river. The truss structure is a mixture of wrought iron and cast iron. The truss configuration is a design patented by Bowman as the Bowman Suspension Truss in 1852. Each span is 79.5 feet long, 25.5 feet wide, and about 21 feet tall, give or take. I tell you the units in meters, but nobody cares. The Bowman Truss suspends the deck from a network of tension members while the top cord resists compressive forces. The system is therefore referred to as a suspension truss. There was also an inclusion of Doric-style vertical members and a cast iron end tower on each end, as well as a decorative protective metal enclosure on the top. Both practical and functional, as you see, it can protect further from decay. Now it's time for trusses and scientific principles, or as I like to call it, the nitty gritty. Yep, we're talking about types of trusses, and if you don't know what a truss is a series of individual members acting in tension or compression and performing together as a unit. On truss bridges, a tension member is subject to forces that pull outward at its ends. Even on a wooden truss bridge, these members are often individual metal pieces, such as bars and rods. Talk about teamwork. Compressive forces which push or compress together are heavier, as the individual members form a triangular pattern. Bridge historian Eric Delaunay describes a truss bridge as, well, the following. A truss is simply an interconnected framework of beams that hold something up. The beams are usually arranged in a repeated triangular pattern, since a triangle cannot be distorted by stress. In a truss bridge, two long, usually straight members, known as chords, form the top and the bottom. They are connected by a web of vertical posts and diagonals. The bridge is supported at the ends by abutments and sometimes in the middle by piers. A properly designed bridge and built truss will distribute stress throughout its structure, allowing the bridge to safely support its own weight, the weight of the vehicles crossing it, and wind loads. The truss does not support the roadway from above like a suspension bridge or from below like an arch bridge. Rather, it makes the roadway stiffer and stronger, helping it hold together against the various loads it encounters. But I will say that before I show you my citations, that did I did experience some of what Daniel is talking about in his synopsis of truss bridges, about when he said that the compression is really what holds the bridge together. When I was building my little model bridge, I tried to put the roadbed in, and all the little roadbed pieces just popped out. But once I got them in there and stably secured, I knew that the bridge was going to stay together because all that compression in the middle, that's really what keeps the bridge together. So without further ado, here are my citations. And I really hope you read some of these books that I put down there as my citations, because they were really helpful to me, and hopefully they'll be really helpful to you, and so are the websites and the articles. And that's my project.